All right. Hi, everyone. Nice to meet you. I'm Liran. I'm the CEO of Aporia, the observability platform for machine learning models. I'm an engineer in my background. I've been working in a startup company that got acquired by Microsoft, where I was responsible for the architecture for machine learning over there. I'm a coder. I love to create stuff. Especially, I love the combination between business and technology. And in my last role before starting Aporia, I worked for a venture capital firm called Vertex Ventures, investing mainly in early stage companies in the AI and cybersecurity. And lastly, but most importantly probably, I'm a proud owner of the almighty cat Tutu. So this is a bit about myself. And today we're going to talk about responsible AI in finance, and specifically how do we take it from a concept to practices and actually implement this in our teams. So as you probably all know, AI is being widely used and for many use cases, right? Ranging from credit risk, fraud detection, demand forecasting, and there are plenty more examples and use cases. And yet, we still see some examples and interesting insights. For example, this one where Steve Wozniak's wife received much lower credit than expected, although they shared the same assets. Another example is Amazon, who were able to successfully build a machine learning model to prioritize job resumes, but yet found themselves to be discriminating women unintentionally. We have the example with Zillow a few months ago, Microsoft with their racist chatbot. A bit funny, yet also kind of black mirror to ourselves as a society, right? Uber with the self-driving car, and I'm asking, responsible AI, are we there yet? So I think we're not quite there yet. And maybe let's talk about what responsible AI is at first. So there are quite plenty of definitions out there for what is responsible AI. The way we see it, responsible AI is composed out of 4 pillars. The first one being performance. How do we ensure that the model that we've built is actually performing as well as we've expected, right? Does it actually meet the business KPIs? This is the core basic for every application that you have running in the organization in general, and there is nothing unique about AI in that sense. Secondly, is our AI working in a fair way? Does it discriminate? AI models usually tend to be black box, and it's difficult to understand how they actually work. And there are so many edge cases, so it's difficult to get to good coverage while developing and training these models. So that's why these models are exposed to so many risks and to so many unintentional biases or discrimination. Compliance. So there are multiple compliance and regulations coming up with the European Union published draft last year in April 2021 about recommendation for regulation around AI. In a way, it is called the GDPR for AI. But still, we have some other regulations in place in the financial industry, for example, like SR 711, that are not specifically targeted towards AI, but still applies on any application that AI might be relevant. And lastly, we have security challenges. AI as technology creates new type of attack vectors, whether it's adversarial example for autonomous cars, whether it's backdoors in the training data. So all these could end up in malicious or unintentional behavior of our machine learning models. So when looking on all of this, it's also important to prioritize and to start to understand where do we really start, right? Because all of them are really important. My 2 cents is usually to start with first performance, then go to bias and fairness. Compliance, obviously, if you have models that are regulated or relating to regulated applications, obviously you should address that. But the very 2 basics are performance and bias and fairness, and that's what we're going to discuss in this talk. So I want to touch why do we have these challenges in the first place with machine learning models. And the main reason for that is that if we have here the model in the center, it is highly being affected by the data it is being fed with, right? So we have data getting into the model, and prediction gets out of the model as an output. Now, this data is being affected by 3 tiers of effects. The first one being the internal data pipeline, which will usually be maintained and developed by a different team than the data science team who developed the model. Then we have the application interface. So we've built a model, right? For example, a loan application model. We want to serve it and to allow users to actually use it. So we need to have it in some interface. It could be a web application, it could be a mobile app, it could be REST API. Also usually being managed and developed by a different backend or software engineering team, sometimes even another company. And lastly, we're living in an environment that is constantly changing. So obviously COVID is the most obvious example for a tremendous change in our life. But all sorts of things are changing, whether it's holidays, seasons, even if marketing department has launched a new campaign targeting students, and suddenly the model is experiencing much more inputs, much more loan application requests from students. So that might also affect the model. And to make it more real, let's take a look about a specific example. So one of our clients, a financial services company, they are using machine learning model to predict which loan applicant, what is the risk in approving loan applicant, which of them will be able to repay the loan fully, and which one of them are likely to default. So the way it works, we have the users. They're able to submit an application either through a web application or mobile app. Internally, these data get into a Kafka queue, which then being fed into a Flask application that serves TensorFlow-based model, which by the end of the day produces the risk for that model, for that application. And based on that, there's a final decision whether this loan is getting approved or denied. Now, in one instance, what happened is that suddenly they experienced that many loans, actually most of the loans, if not almost all of them, are getting approved. Now, I want to ask you a quick question. Do you have any idea or guess what happened? Yeah.
Was it fraud?
Well, no, it wasn't a fraud.
Because fraudsters are normally really good at reverse engineering.
Any other guesses? All right. Oh, yeah.
Criteria which it generalized was all approved loans.
So sorry, I can.
Criteria which it generalized was all approved loans. So maybe it looked at the data set and all of them were approved or most of them.
So you're saying that the generalization didn't work?
It was just more in favor of approving loans because the available data was mostly approved for applications. Just a thinking guess.
Yeah, interesting. So it's not the case, although it could happen as well. One last guess? Yeah?
We have a good sales department and they learned the model.
So the
fill out the right boxes.
yeah. So what happened here is suddenly their customers became, sorry, my mistake. So what happened here is that a new version of the web app got released to production by a new developer at the team. And apparently, this developer seems to be looking at the income feature as annual basis, while the data scientist who developed the model developed it on monthly basis. So this just confused the model and suddenly, starting to get 12 times higher income rate than what it used to. So obviously, we should approve these guys' loans, right? So this is just one example of what could happen in production, what could happen with this model, because there are so many changes. So going back to our diagram, there's so many things, whether it's, again, the data pipeline, the applications, the world itself, so many changes. You also gave some examples that, could be real. And the examples I gave before, these are just few examples that got out to the media and to the public, but the same way that software has a lot of bugs and issues, and they happen on a daily basis, even if we don't hear them on the news, the same thing happened with AI. So as we are short in time today, I want to focus on 4 quick wins that you can implement within your teams to implement responsible AI. So starting off with our first quick win, which will be creating a visibility to your models in production. So we've invested a lot of time, weeks or even months on building our model. Finally, we deployed it to production, which is exciting. Now it's important to understand whether it's working or not. How many loans are getting approved? Which loans are getting rejected? Right? So having a centralized place with a dashboard that you can see all of this information on demand, it's really crucial. Moreover, we should focus here on specific data slices. This will help us both identify potential bias in the model, or some errors, or some potential actually to improve the model. Because usually when an issue happens in production, it doesn't happen for all of our data points. It will start for a specific slice, for example, data from a specific data source, right? So if we were to look only on the overall performance, it would be assumed that the model is working just fine. But having visibility is crucial, for example, to visualize and see whether women in Alabama are getting the same treatment as men in California. So this is really crucial. It's also important to store your data and to version it with tools like DVC, so you can actually investigate these things when they happen. So if you've either identified such an issue or you got complaints for something is wrong with the model, then you have the abilities to go back in time, filter out just the relevant data points, and start to investigate what is the common denominator for the issue, so you can find the problem and remediate it. Here below, we can see some relevant tooling that could be available, that could help you in that. So weights and biases, Pachyderm, MLflow, this could help with tracking the experiments. DVC could help you with versioning the data and the model themselves. And also, by the end of the day, it's important to save it in some data store. It could be Kafka. You can use S3 buckets. You can use whatever solution is available on your cloud. But it's important to do that. So once we have that, let's move to our next quick win, which will be becoming proactive from being reactive. And I've experienced it firsthand when I worked in Adallom, where our customers came to us telling us, wait, I have something odd in your system. Can you look into it? So ideally, you want to find it out before your customers does. So the best way to do it is by implementing some alerting capabilities in place. And when tracking these things and creating alerts, it's important to understand what are we tracking. So because there are so many edge cases in AI, right, and we don't know all of them, so it's difficult to say what is the unexpected behavior. So instead, we'll take the opposite approach. We'll define what we do know, which is usually what a data scientist have gone through during the training phase. They know the data pretty well. They know their model very well. So they know what to expect with regards to distributions, with regards to business KPIs. So it's important to set alerting for things that are out of the norm, because there are much more things that could get out of the norm than things in the norm. And lastly, it's also important to integrate this kind of alerting mechanism with the existing Slack communication, with the existing communication system that you have in place, whether it's Microsoft Teams, email, Slack, so people can react, can communicate, and it's important to engage into discussion about this stuff, right? A lot of times we see organizations where the data science team is responsible mainly for developing the model, doing the research, and once these models reach to production, they're kind of end-off. So it's important to engage them, to make them take responsibility, and also, see the upside by doing that. So they can also learn new insights about their model, so they can improve it in the next version. So few tools that can help you with that. As for alerting, you can either use Alert Manager by Grafana, you can use New Relic or Datadog, you can use Aporia. As for incident response, there are tools like PagerDuty and VictorOps, which are currently part of Splunk. Ticketing is also important for keeping track of what we actually do with these incidents. So you can use Jira and ClickUp, and communication channels. I guess you have something in place already. So third quick win. So we have visibility, we have alerting capabilities. Now the question is, when do we discuss these subjects? Okay, so ideally it's good to have a cadence for having maybe weekly, maybe bi-weekly meeting with all the relevant stakeholders, data scientists, engineers, operations team, and business stakeholders or product managers to take a look about all the metrics from the past 2 weeks, maybe even take a wider time frame, and analyze what is the current performance that we're experiencing versus the business KPIs. Are we reaching these goals? List what questions does it raise? Usually when looking at the data, questions are starting to come up. So it's important to list down these questions and also set action items an owner for each of these action items, and start the next meeting by actually reviewing the action items from the past meeting and see where have we gone until now. For having such capabilities and having this reporting, you can use Grafana and Prometheus. Summaries, you can use Notion, email, and other system that you have. And fourth quick win that we can create in the organization is creating an incident response workflow. And what do I mean by that? So when something burns down, everyone is on a rush. Everyone is, everything is hectic. Nothing is working as usual. So instead of waiting for something to burn down, it's better to think of it ahead of time and set a well-defined workflow to what happens. So first, who's the one to take charge and actually react and respond if something goes bad, right? Do we have someone on call? Is it an engineer? Is it a data scientist? Maybe it's two-tier support or something like that. But we have to have this person who takes responsibility. And then because something urgent happened, it's important to have a well-defined list of questions with workflow. What happens, like a decision tree. So how do we know if this is urgent enough so we need to wake someone up in 2 a.m. in the middle of the night? Or can it wait for tomorrow, maybe even next week? So it's important to list these questions and say, and understand how urgency is determined. It's also important to use some fallback mechanism and to have them in place before reaching that stage. Okay, fallback mechanisms means that we have some issues with our machine learning model. It doesn't really matter in general, what is it? But we have to have multiple mechanisms. Mechanism like that could be reverting to previous version of the model. Maybe that one worked well. It could be involving human in the loop. So starting off right now, when I click on this button, every new request that will get to the model will also get to a review by a human analyst, for example. It could also be activating, usually before machine learning gets into the picture, there was another algorithm, another heuristic in place. So maybe we should revert back to that and activate that until we'll solve the problem. And for worst case scenario, ideally we won't reach there ever, halt production. And then after having such an incident, we should sit together, all the people who got involved, whether it's the developers, whether it's the one to take responsibility for the incident, and investigate what happened. So a list of questions that could be helpful is what happened, what should have happened instead, right? What's the gap between the answer for these two questions? What do we learn from it so next time will be better? It could be from before the incident happened, during the incident, and afterwards. And lastly, again, list of action items with clear ownership so we can make sure that the next time such an incident will happen, things will look differently. For managing that, you have tools like Lucidchart, Microsoft Visio. You can define the workflow. It's important to share this workflow with the relevant people. And you can use incident management systems like OpsGenie, PagerDuty, ServiceNow, and Atlassian. Just to summarize these four quick wins. So for starting to implement responsible AI today in the organization, and not just talking about it theoretically, it's important to have visibility, dashboarding, alerting system, so you can be ahead of time and be proactive, conduct reoccurring production review meetings, and create a workflow for incident response. And these are just the essentials to start with. There are plenty more things we can do even earlier in earlier phases of the pipeline, like how do we avoid it in the first place when we deploy to production, how do we do it during the research phase, but this is for another lecture. And I want to end with a quote by Stephen Hawking, who said that AI is likely to be either the best or worst thing that happened to humanity. So by doing and implementing these practices, we can make AI the best thing that can happen to humanity. So I was Liran. Feel free to reach out to me on LinkedIn or email. Thank you very much.